Here we have honors algebra 2 math question. Okay, let's go over the question. Find the sum of all 3-digit natural numbers which are divisible by 7. Okay, so here we have the 3 steps. The first step is we have to write all 3-digit natural numbers, and the second step is among all 3-digit natural numbers we have to identify the numbers which are divisible by 7, and the final step is we have to add them all. Okay, so the very first 3-digit natural number is this 100, because before 100 we have 99. It contains only 2 digits. The first 3-digit natural number is 100. The second one is 101. The second one is 102. The third one is 103, and it keeps going. And the last 3-digit natural number is 999, because the next one is 1000. It contains 4 digits. Okay, now I have written the 3-digit natural numbers. Now, among these 3-digit natural numbers, I have to identify the natural numbers which are divisible by 7. Okay, to identify the 3-digit natural numbers which are divisible by 7, I'm just going to divide the first natural number 100 by 7 using long division. Okay, so 7 goes into the first digit 0 times. So let me take the number formed by the first 2 digits. So 7 goes into 10 1 times. 1 times 7 is 7. When I subtract 7 from 10, I'll be getting 3. Okay, let me bring this 0 down. Then I'm getting 30. How many times 7 goes into 30? 4 times. So 4 times 7 is 28. When I subtract 28 from 30, I'll be getting 2. Okay, here I'm getting remainder 2. When I try to divide the first 3-digit natural number 100 by 7, I don't get the remainder 0. I get the remainder 2. Since I don't get the remainder 0 when I divide 100 by 7, so the first 3-digit natural number 100 is not divisible by 7. Okay, so what should I do? So should I check 101, the second 3-digit natural number is divisible by 7? In case if it is not divisible by 7, should I check the third one? And if that one also does not work, should I check the fourth one? So it will be time consuming. It will take a lot of time to check one by one. So to identify the first 3-digit number, 3-digit natural number, I'm just going to have a trick over here in this long division. So what I'm going to do is I'm going to subtract this remainder 2 from this divisor 7. So 7 minus 2, I get 5. Now I have to add this 5 to the dividend 100. So what will I get? 100 plus 5 equals to 105. So this is a simple trick. So 105 is the first 3-digit natural number which is divisible by 7. So I subtract the remainder 2 from the divisor. So whatever result I'm getting. So here I'm getting 5. When I subtract the remainder 2 from the divisor 7, I'm adding this result 5 to the dividend 100. So this trick will not only work for this particular case. Even if you want to find 3-digit natural numbers which are divisible by 8 or 9 or 10, or even for 4-digit numbers. So any problem similar to this one, the trick what I've explained over here in this long division will work. So 105 is the first 3-digit natural number divisible by 7. Okay, what is the next 3-digit natural number divisible by 7? To find the next number, it's very simple. You just have to add 7 to this 105, because we are trying to find the numbers which are divisible by 7. So to get the next 3-digit natural number divisible by 7, you have to add 7 to this 105. It will be 1 and 12. So to get the next one, again I have to add 7 to this one. I'll be getting 1 and 19. So in this way it keeps going, and we have to find the sum. That's why I'm adding the 3-digit number, 3-digit natural numbers which are divisible by 7. Okay, now my aim is to find the last 3-digit natural number. For that, let's take the last 3-digit natural number and divide by 7. So 7 goes into 9 1 times. I get remainder 2, and I can bring this 9 down. 29. 7 goes into 29 4 times. 28. I get remainder 1. So now I bring this 9 down. 19. So 7 goes into 19 twice. So 2 times 7 is 14. I get remainder 5. So the last 3-digit natural number 999 is not divisible by 7, because we don't get remainder 0, we get remainder 5. Okay, here what is the idea? So should I check the previous one, 998 or 997? No, we don't have to do that one. So again, there is a trick to get the last 3-digit natural number which is divisible by 7. For that, simply subtract this remainder 5 from this dividend 999. When I subtract 5 from this 999, I'll be getting 994. So 994 is the last 3-digit natural number which is divisible by 7. Okay, among all the 3-digit natural numbers, I have identified the natural numbers which are divisible by 7. So they are 105, 112, 119, so up to 994. So clearly, when I look at this series, clearly it's an arithmetic series because the difference between the first term and second term is 7. The difference between the second term and third term is 7. So the difference between any two consecutive terms along this series is the same, that is 7. So clearly it's an arithmetic series. So we can use a formula to find the sum of the terms in this arithmetic series. So the formula to find the sum of the terms in an arithmetic series is going to be Sn equals to n over 2 times a1 positive an. Here n stands for the number of terms in this series, and a1 stands for the first term and an stands for the last term. Okay, here already we know the value of a1 and an. So because an is 105 and an, the last term is 994, we can plug in that. But still we need the value of n. So there is a formula to find the value of n. So the formula to find n is equal to the last term negative the first term over d positive 1. Okay, here what is the last term? 994 negative, and the first term is 105, and the d stands for the common difference, which is 7 positive 1. Okay, when I subtract 105 from 994, I'll be getting 889 over 7 positive 1. When I divide this 889 by 7, I'll be getting 127 positive 1. So finally I'm getting 128 as value of n. So that means there are 128 terms in this arithmetic series. More clearly, there are 128 3-digit natural numbers which are divisible by 7. Okay, now we have to plug in n is equal to 128, a1 is equal to 105, and an is equal to 994, and we have to evaluate it. Okay, let me do this one on the next page. So let me write the formula again. Sn is equal to n over 2 times a1 positive an. So here n is 128 over 2, and a1 is 105. Positive an is 990 for the last term. So when I simplify this one, 128 by 2 will result 64 times. When I add these two numbers, that results 1999. When I multiply the 64 and 1999, it will be 70,336. So the sum of all 3-digit natural numbers which are divisible by 7 is 70,336.